everyone, and welcome to our video on trigonometric identities. So in this first video, we're just going to define what an identity is and show how it differs than an equation. So an equation is a statement that two expressions are equal. So anytime you have an equal sign, it's automatically an equation. An identity is an equation, so it's a special type of equation that is true for all values of the variables. So for instance, in this problem, both of these are equations, but only one of them is an identity. So for instance, this first one is an equation and only an equation, not an identity because it's true only when x is 17, because 17 minus 7 is 10. So this is an equation, not an identity. Okay, so it's true only when x is 7. Is only value that makes it true. Makes it true. We fit it. Okay, this number 2, this is an identity. Okay, so this, I'm going to put it here. It's an identity. So we can plug any x that we want into this and it will always stay true. So for instance, like sine squared of 0 plus cosine squared of 0 will equal 1, because sine of 0 is 0. Cosine squared of 0 would be 1 squared. 1 squared is 1. And we could choose anything we want. So let's do like sine squared of pi quarters plus cosine squared of pi quarters. So sine squared of pi quarters, that would be square root of 2 over 2, but it'll get squared, plus cosine of pi quarters is also square root of 2 over 2, also squared, a little near the edge there, but when squaring this, square root of 2 squared is 2, 2 squared is 4, and then same deal, and that does equal 1. Yeah. And you could do it so as much as your heart desires. You can plug in anything that you want in here. So like negative 53 pi sixth, as long as it's the same x value, it's always true. Okay, so that will be true. Let's not actually do it. It will definitely be true. Okay, so in this next example, we're going to show that something is not an identity. So all we have to do to prove that something is not an identity is just find a single x value that will prove that the equation is not true. So if you choose an x value, so for instance, like if I chose x equals 0 here on this first one, it might look like an identity because sine of 0 is 0, cosine of 0 is 1, and that looks like it's true. So, but it's a bad choice to prove that it was not an identity. Let's choose a different value. So for instance, let's do x equals pi. So sine of pi plus cosine of pi, that will prove it, because sine of pi is 0, cosine of pi is negative 1. So now it's saying negative 1 is equal to 1. Okay, so x equals 0 is a value that proves that it's not an identity. So to prove something's not an identity, it is just find any value. And there's an infinite number of answers here. You try different values on the unit circle, you'll find one. Okay, so this, and this one also still saying, oh, this is definitely not an identity. Again, choose your value wisely and then just double check. So for instance, let's do x equals, let's do, I don't know, how about 3 pi over 2. Okay, so when we do that, we would have square root of 1 plus cosine squared of 3 pi over 2. And then we want to see if the right side will equal the same thing. So 1 plus cosine of 3 pi over 2. And then, well, cosine of 3 pi over 2, that is 0. So that gives us the square root of 1 plus 0. And over on the right, 1 plus 0. So, that's not a good value again. So I made a poor choice. So let's show it by doing some other x value. Okay, so this was no good. Try one other one. All right, how about we do... Let's do pi again. Okay, so I think pi is fine. So we've got 1 plus cosine squared of pi equal to 1 plus cosine of pi. Okay, so this left side, so ran out of little room because of my bad choice the first time, but cosine of pi would be -1, but it's getting squared, so it would be 1 plus -1 squared equal to 1 and then plus -1. Well, the left side looks like it's the square root of 1 plus 1. The right side looks like it'd be 1 plus -1 is 0. And then from here we can see, oh yeah, square root of 2 does not equal 0. Okay, so there we go. So x equals pi again is a good one. Okay, so it's not necessarily always just choose x equals pi, but on these problems it worked well. And again, you can find more values that will definitely show that these are not identities. So an identity will mean it always is going to be true for any x value. Okay, so there's our introduction. If you do have any questions, please let me know. Otherwise, thanks for watching.